So, hardly any other industry is currently as much in focus as the automotive industry. No wonder, because in many countries, it is the driving force behind the national economy and is currently on the edge of an imminent transformation, which will take place a little faster, I guess, than one might have imagined. The pandemic, in combination with a growing awareness for sustainable behavior, has given a boost to electromobility and thus to a fundamentally different business model if we look at the entire value chain of the product. Even though all manufacturers have been dealing with the topic of 3D printing for quite some time, we can still see big differences in the degree of maturity of the various players. Today, we want to exchange thoughts with experts from the industry about which application they are currently focusing on, which use cases they know, and where the journey is heading. I would like to welcome here in the studio Mr. Markus Schnell, Manager for Additive Design and Manufacturing at Conti. Welcome, Markus. Good to have you. Have a seat. Thank you so much.
It's a pleasure for me to be here.
How are you?
Thanks, fine.
It's good to have you here live. But we have two other guests. We have connected digitally. Martin Bock, Project Manager, Metal 3D Printing Center of Audi. Hello, Martin. Good to have you on board.
Hello.
And now it's getting
Nice to meet you.
now it's getting difficult because there's another Martin here on stage. Martin Hillebrecht, you are Senior Expert Innovations at EDAG Group. Hello and welcome to the Formnext Connect studio. Good to have you here. Thank you. So, Martin H., I would say, Mr. Hillebrecht, let's start with you. Can you briefly explain your role at EDAG and where's your starting point for additive manufacturing?
Yes, Martin Hillebrecht is my name. I'm since more than 20 years at EDAG, and as innovation manager, it's my goal to be a good technology scout and to see much of innovations in our branch and to implement them in EDAG, within EDAG. My task is to initiate new projects, to initiate new ideas in cooperation with other partners. And I'm very proud on it that we have initiated projects like Hinge Plus, like the next gen space frame 2.0, or in power electronics cooling plate for BEV technology carrier, and so on. And to implement this in cooperation with the leading partners like Siemens, Constellium, BLM, Fraunhofer, IAPT, and others, Simufect, Eric Lemp, and such guys. This is, I would say, my main task, to push this theme forward. And I would say my starting point is more than 20 years experience. We have invested in the first machine end of the 90s at EDAG, but later we made the decision not to invest in an own machine plant. For us, it is very important to implement it in the engineering processes, to push those processes forward and to be very reactive in cooperation with partners which are providing the manufacturing capability and the most innovative manufacturing processes in additive manufacturing.
Great, thank you so much for the insight. Markus, I mean, you're representing a big supplier, must say. So suppliers are often the innovation driver in the automotive industry. What is your function at Conti and what is your area of activities in additive manufacturing?
So yes, my function for sure is the operation and the development of our competence center for additive manufacturing, which we have built up in the last 3 years. Actually, we grow very quick and very fast. And for sure, there is another task. The function is, from my group, to ensure the availability of additive manufacturing in the company, so internally and also externally. And the main function grows this year at mostly, I think, is that we got a next step and bring the additive manufacturing into the series production.
Mm-hmm. Great.
And to the areas it's okay?
Yeah, absolutely. Go ahead.
Okay.
Go ahead.
For the areas you also ask, I think I can combine it to main topics. For sure, we have high quality samples in plastic and metals, all of that. We have research projects with universities, with own research projects with suppliers. And I told it, the series production and tooling and devices at all in our whole company.
So do you have a machine park, or do you have machines in your
Yes.
center? Or
Yes.
what kind of machines are that?
We have this competence center. It's around about 600 square meter with metal and plastic machines and very different technologies, so that we have a good technology part for very different use cases.
Great, great. Martin, I mentioned it at the very beginning, the intensity of the AM activities of car manufacturers, they varies widely, because you probably, as well as I do, know a few of them, and totally different stages and focuses. How intensively do you deal with AM at Audi, and what is your specific role in this?
Okay, so my name is Martin Bock. So my specific role is I'm the project manager for metal additive manufacturing. So very focused on metal. So we have another competence center for plastics. So this is located in the technology development department. And yes, my role is to deal with metal AM technologies. So mainly we have 3 machines. So that's also the question, what is our machine part? So we have 3 machines, 3 materials to support our engineers with very fast parts. So we can deliver within some days parts from aluminium or from steel. And if there is a higher demand of parts, yes, we can react with the market. So we deliver this.
Great, thank you. I mean, we were specific talk about mass production, of course. Today we are talking about automotive industry. So, I mean, Markus, the technology is certainly exciting, but as a supplier, and I know of you, you are much more focusing on bigger volumes, right? Now we are still talking about a small volume topic. Where are the greatest benefits for Conti in AM, or why you are focusing on that topic?
Sven, I think that's a very good question, because there are a lot of interests for us in small volumes, because in the past we can't deliver this area from part 1 to 10,000, for example. And now we got a chance to close this gap. And everybody know about rapid prototyping, right? And now let's talk about rapid series production. I think it is time. The technology is good enough to do that. And that is the benefit, what we can support to our customers. Very quick, very good, and very fast, and very smart parts, products to our customers. And in this case, we look on the entire process. So that means we don't just look at the production. We look from the first sample to the end, to the aftermarket. And in every step, it's for sure we can find opportunities to use additive manufacturing, and we save time and money with that, for sure. At some point, we got a break-even point where conventional manufacturing is more cheaper than the additive manufacturing. But with projects or for projects with high time pressure, I think we got a very strong weapon to handle these projects, I think.
Talking a little bit more about the regular car, can I imagine that there will be a time where I have a defect part in my car, I walk into a garage and this part is a Conti part, yeah? And then the mechanic says, no problem, I print it quickly for you. Is that something I can imagine in the future? Or?
I think it's not for the future, I think it's next year.
Okay, cool.
We already have small series products for additive manufacturing, and right now, and I already told it, it is my function and my task to get all the certifications in Germany. You know, we have a lot, But it is necessary. It is necessary to do all that to make every process serious, so that you can that you have the opportunity and the possibility to look at every process and can do it every time again at the same way.
Mm-hmm. Great. We will come back later to this with a cost point. That would be interesting. Martin, at Audi, your department is located in the production, which in my opinion is very good, to be honest. It's a good way to do it. So you are measured against the key figures of production. I mean, this is what they look at you. I mean, I'm actually negotiating about an e-tron, but if you look at the A4, this is, can you use technology in such a production, or would you say this type of volume will never be touched by additive manufacturing? Oh, sorry, we can't hear you. I think you're muted.
Okay, yes, sorry. Of course, the A4 is a high volume part. So I think there is no chance to get direct parts manufactured by AM technologies in the car. There are faster technologies. The conventional process chains, die casting, injection molding would be faster, also cheaper. But I see there could be a possibility in the indirect way. So we also manufacture sheet metal parts. So therefore we need tools. And these tools could be made by inserts. There are different inserts, and these inserts could be manufactured with AM technology. So we do this, yes, of course.
So there are already
for instance, in the hot forming process with conformal cooled tooling gels. Yes, of course.
Now you have such a 3D printing center at Audi, and you have quite a huge machine park, but you are working in a group. I mean, we are talking about the Volkswagen Group. Is there a lot of exchange between the other members? I mean, you have brands like Bugatti, for example, where they, of course, can profit from your experience and say, hey, let's call Martin and get in touch and see what is going on. How is this communication flow inside the group? Because yesterday we had Martin Goede on stage at the executive panel. So is there a regular exchange inside the group?
Yes, there's a regular exchange between the experts and also between the management. So, and also if you have some parts to produce, so we manufacture parts for MAN, for Bentley and so on. So there is also not only the knowledge exchange, yes, that's true. We discuss even all 6 months topics about AM technologies in these circles, and also parts, of course. So yes, there is an exchange in the Volkswagen Group.
Great. Martin, the OEMs deal with additive manufacturing. I mean, I see all of them having some activities, and they are making rapid progress, as we hear from Martin. How do you see the role as a development partner? Because EDAG is very well known as a competent development partner. You say you don't have an own machine park, but you're looking into the technology and you're developing solutions. But how is that cooperation going on with the manufacturers or suppliers?
Yes, so the cooperation is not changing very much or significant, but additive manufacturing has, I would say, mainly the same impact on the development cycle times and the development costs. This would be the, I would say, mission, like the introduction of CAD or CAE in the 90s and in the 2000s. To compare it, during the development process of a whole vehicle, we need on many stages development hardware. And there's, I would say, the key impact to make the development process of a turnkey vehicle project more efficient, to find these places. So we talk about prototypes, we are talking about hardware for testing and validation of components. And when we look a little bit forward, we see many niches for the individualization of vehicles in the interior, exterior. So this is a little bit more exclusive customer part. spare part provision. So many tier ones are always and also thinking about new value chain and how to provide spare parts for the future vehicles and to reduce costs in logistic and stocks, jigs and tools. And yes, sooner or later, spare parts for old-timers and classic cars, these are, I would say, the main market fields beside the typical prototype business. EDAG is implemented in many niche cars and high-performance vehicles. These are typical derivatives of vehicles where EDAG is involved in the development with low volumes. And very often EDAG is also commissioned as a manufacturer for small series in volumes underneath 1,000 vehicles per year for the manufacture of body in white structures or for the complete vehicle. There are many references. It's a very confidential business. And due to this, we are preparing these processes to be a readiness partner, which is able to provide a body in white structure or vehicle structure with the implementation of additive manufactured parts in a toolless and variant intensive, low volume production. So this is our own motivation beside all the engineering processes. And what I would say, the car makers are making rapid progresses. And what is the role of the partners? So the role of the partners is to be open-minded, to bring ideas into the system, and to find the right entrance point, hand in hand with our community, to find the right starting points together with the car makers. It is sometimes a little bit luck to find the right place and the right project to be part of it. And I would say it needs a motivation to be prepared for the materials, for the quality standards, and for the reactivity which is necessary in a car-making project.
Great, thank you. Martin, coming back to smaller series that Martin just mentioned. So you're going into this electromobility phase now, especially at Audi. I mean, you launched now several cars in the group, even more. So there's a big range of e-mobilities going on. I just read this morning that 4 or 5 vehicles now are the ID.3. So I would say this is running well due to the current support by the state. So where are we going to see in the near future additive manufactured parts in those smaller series or in this kind of production? Where do you see parts?
Yeah, so talking about the future as a car maker is even a huge business, of course. So there are some cars, of course, individualized cars, sports cars possible. So we think also in these small series production. So highly individualized cars, maybe with more performance or so on, this could be possible. But Martin has mentioned from EDAG, he mentioned that some specialists have to be integrated in the process. So I will underline this a little bit more. That's really the main task for the future, bringing specialists together. I think AM technology and AM manufactured parts needs multidisciplinary teams. Design, engineering, quality management, also material scientists are, and also we as production specialists are needed to be successful at the end of the day.
That leads me to the question, but no, I have the question in mind because I want to ask Markus first something. I mean, we heard it's getting more and more digital, and there's a change at the supplier side as well. Can we imagine a digital warehouse at Continental where you say, okay, this variety of parts is only kept digital, and whenever needed, we print it? I mean, you mentioned next year we will see the first spare parts delivered via 3D printer, but Yeah. Is there already a digital warehouse in place or planned, or how can I imagine that?
I think the mind of a digital warehouse will be very great. And think about that. I talk to my colleague in America and say, here, I send you, or you find a spare part at this server. Please download it, print it out, and build it in your car. But that is not the whole truth, I think. I think that's fact. Additive manufacturing, we have high quality material, but we are not able to print functionality surfaces so far. We have technologies, they are able to, but not in metal and not in plastic, for example, SLS production with powder bed plastic. So we got rough surfaces. Mostly the rough surfaces, they're okay. But for functionality surface, we need to mill and drill them like in the past. So I think, Martin, you can correct. That's right?
Yes, that's right. Yeah. From my side, of course. So AM parts are mainly raw parts. Yeah, and they have to be milled. They have to be finished. And also coated, for instance, sometimes. So, of course, that's true. And it's a complete new process chain needed there.
Yeah. And the digital warehouse, we already implemented it in Continental. And that's one of our steps. And the beginning is a big community in the company to get all the colleagues together and that we can build it up. And you can imagine in a company such like this bigness, and it is very difficult to get all colleagues together and get the information. There is an additive competence center. You can use it right now.
Yeah, that's will be one of my next questions, how to convince the colleagues. But Martin, first to you. BMW just opened their 3D manufacturing center or development center. Is there an exchange between the OEM, or does everybody says no, we do our thing, you do your thing? What is going on there?
That's a difficult question. I didn't want to answer it right now. Okay.
Okay. Good for you. No problem. So we have some technical questions from the audience. If you don't mind, I would give them to you, and you might answer them, and then afterwards we keep on with our discussion. So there's a question: is there an automotive industry area where AM has not currently broken into? Where does it need to improve in order to gain further ground? I don't know who wants to answer, Markus. Do you see any area where there's no chance for AMM right now? And
I think Mr. Hillebrecht already told it. The huge volumes, I think we can't replace them.
Okay.
The casting technologies, you can't replace them with additive manufacturing. So I think in the high serious production, for the future, I think there's at the moment no possibility for additive manufacturing.
Then again a question to all of you. Feel free to pick it. What percentage of AM technology is used in the production process of electric cars, hybrid cars, and gasoline and diesel cars? So I think there's a ratio meant. What are the future prospects for the use of AM in the production of these class of cars? Mr. Hillebrecht, probably one for you.
Yes, I will try it. So I want to also underline a little bit the first question. Additive manufacturing doesn't make sense in the real mass production of a base vehicle. There's a long tradition in the press shop, in the casting, and in the plastic machinery, high volumes, etc. And we have a high cost pressure and quality standard. And in case that we are seeking entry points and starting points where additive manufacturing makes sense, we need to think about a high degree of functional integration. And when we have problems like cooling of components, and when we have a diversificity and variant-intensive design behind us, then it makes sense. So in combination with alternative drivetrains, we have a much higher impact to change our processes for low volumes.
Great. Good answer, in my opinion. That's an interesting one. So if it comes to polymers made with AM used in automobile manufacturing, are they recyclable? So is there already a recycling process in place? Martin, you mentioned you are focusing on metal, but you are in touch with the plastic colleagues. So is there recycling going on? Is it a reuse, Markus?
Yes, we use it. We already reuse it, and I think I always talk about powder bed printing technologies, but also in FDM we have technologies to grind all them together and got new filament. You can't do that often that you like, maybe 2 or twice times, 3rd times. In SLS technology, you can use half of the old powder again, and what we do, we save all the old powder, and we make once a month or 2 in a month build jobs with old powder. And the quality of these parts, the surface is not that good, but our facility management, they love it because they use it for every tooling in the plants. They use it, for example, for garbage, for example, or for machining, anything. And I think that's for the next point of view, what you have on your list.
Yeah, no, I mean, I think we addressed the sustainability topic quite a lot over the last 1.5 days, and I think there's the most potential in sustainability here. So, Markus, you said in our pre-conversation there is already a part running. I mean, we are always talking about tooling and we're talking about prototyping, but as far as you told me last time, there is a part outside. Can you tell us something about that?
Not the details for sure
at
the moment, because of before SOP, I can't talk about that. But it is, in fact, pretty simple. We are starting with the beginning samples, very often with additive manufacturing right now. And they are not that cheap, but they're very quick. So when we have a customer, we are able to bring the first prototype in 2 or 3 days to the customer. So that's save time. Mm-hmm. And now when you look on the entire process of the whole product life cycle, and that what we do, we're starting with the sample. Then the customer say, oh, great, 3 days, just 3 days, and you have the first sample. Oh, this looks nice. Okay, and then we start with another sample, printing them 2. And when you look more in the future from this point, for example, you have a metal printer, and you print the prototypes on that. So the same printer can print also the series production parts. And for all the automotive experts, they know we have 2 validations in our development. There is a design validation and there is a product validation. And these validations are very expensive. And the big difference between them is from the development, from the design validation, you just use samples. And from the series validation, you use products out of the series production. Mm-hmm. And think about, you use at the beginning the machine, what is used after for the series production. So you can combine this validation into one big series production, save the money from the design validation, and that's the important thing. And that was the reason why we are able to print series produced small series parts, because we look at the whole process and we save the money in the development. And there's one important point, I think, our controlling. They understand right now, time is money. And especially in development. For example, we save in development. At the end, we don't produce it with additive manufacturing, but we produce the whole samples and we save nearly 3/4 of a year. This was a lot from 2 years, so we save a lot. And that's, I think that's a very strong thing from additive manufacturing. And for sure, when we come to the point where we look to casting technologies, they're cheaper. And you have to look on every product very clearly and to check it. Don't do it when it is more expensive overall.
Total cost of ownership, so the total cost perspective would be interesting
Exactly.
here. Are there, Martin, parts already where you would say in a smaller series, AM could be cheaper due to the reduced development process and validation process? Is there already a positive use case in the automotive industry?
Yes, there are some positive use case in the future. There would be some, yes, of course. I will underline this development, also the phases for the development. So we can shrink dramatically these times we needed in conventional manufacturing methods through using AM technologies. So, of course, I will underline this, that's absolutely right. You mentioned in your talk. And of course, we see some good parts will coming up, of course, more in the group, more in the Volkswagen group.
Martin, yesterday in the executive panel, we discussed the topic of standards that needs to be established. I mean, we haven't addressed it yet, but you said there are 2 verification processes going on, which has to do with standards as well. So, Martin, do you see already enough standards? Who needs to bring in the focus on standards? And is that something that touches your work? Your daily work,
yes,
missing standards?
Yes, it touches my work directly. So buying powder means you need to clarify with the deliverers the standardization and the process of quality management, also the issues of the powder. You have to also survey internally. And of course, a little bit more standards could be better to have a more secure view on the process chain, of course, yes. That's also the big gap, yes. So in this case, we are 4 persons in AM manufacturing metal, so for the parts. We are dealing also with our departments, with the quality department, also with other departments, also with the engineering, and to optimize the construction of parts, if possible, for the AM process. Also, there could be standards or more basic knowledge broaden to the companies, of course.
So coming from standards to quality management, I mean, I worked in quality management a while. So do they have, I mean, the quality process is changing tremendously if you're doing additive manufacturing, right? I mean, it's very much is done up front. It's not so much, I mean, you can go into a, let's say, virtual testing up front. You can simulate a lot. So can you work with the current quality management resources? Are they qualified, or do you need to work closely with them together to bring them up to speed in that new technology?
Yes, so we have to work closer with them. So also we have to develop new instruments for that. We print the part, of course. We see the process. We observe the process exposed. After the process is finished, then we have the part. Then we see, okay, everything is running good, perfect. Sometimes it fails, it could be failed. Why? That's also a big question. And are these failures in the manufacturing process infecting the part quality? Is also a question, a big question. And also the automated process. So for that is of course one of the big issues, and could be also one reason why we are not in the series production. Yes.
Great. Just another question, Mr. Hillebrecht, Martin. We talked a little bit about qualification last time. You mentioned classic cars, or let's say later on, spare parts where you don't have the tool anymore, or the tool is not longer in the status that you can use it. There is a specific qualification needed for doing reverse designing, for example, reverse development, and we strived a little bit. And I've heard through the days that there is a problem with qualification coming up, dealing with a new technology. How do you see that? I mean, at EDAG there are so many developers working, so many engineers. How do you bring them up to speed, or do you need to hire new people in order to deal with the topic additive manufacturing?
So this is a theme which is, I would say, a permanent learning is necessary, and to combine both. On the one hand, the high motivation of young people which are able to work with the tools and which are understanding very fast the, I would say, actual methods, and to combine it with the experience of people which has high experience with the product itself, with the load cases, and have seen many solutions before. So in this combination, this is I would say, most efficient learning process. So the one can learn from the other. And sooner or later, it's necessary to qualify the development team with the engineering, with the manufacturing processes, and to bring this in motion. Personally, we have good experience with building up knowledge in cooperation with other players, with partners, covering the whole process chain of additive manufacturing, starting with the material, with the processing, with the engineering and the methods to dimension an additive manufactured part and the testing of parts. So in this combination, this is, I would say, the optimal skill profile. And yes, not all of these competences can be learned at the university in the moment, and you need practical experience with it. To make all the learnings, the quality level is high in the automotive industry. The automotive industry is demanding reproducible and stable processes. The automotive industry is not applying processes which are 100% inspected parts. So we need stability, robust processes, and inspection ability in the assembly line. And I would say the most important success factor is, beside the qualification, to influence the costs of materials, of processes, to bring them more down in the next years again, to be more competitive, also in the niches and in the small series manufacturing applications.
Good answer, good answer. Thank you for that. One more question out of the audience. There are several more, I must admit. I can't ask them all. If you don't mind, we will forward them to you and you can answer them quickly or afterwards. So what is the main limitation in current AM process in automotive industry? Is it build volume or build time or any other? Markus, what do you think?
I want to pick up the point from Martin Hillebrecht. Yeah. He told we have the pre and the post processing, and I have a huge list on my office table with things to do to bring it in serious production. And in fact, it is not the printing itself; it is the pre and the post processing. There we need automatization. Most of us think about automatization. Yeah, for sure, there are robots working with all the parts, but that is not the truth. The truth is to standardize all the process, to make sure that everything is done the same in the future and everything is done by the same way. Think about the powder. When you print metal powder, we reuse 95%. So you have a supply cylinder filled up with 95% old powder, recycled powder. Then you need to fill it up with 200%. So you fill up with 5% new powder. And then you print. So means that you have 5% new powder in your part and 95 old powder. That's not good for serious production. So means you need to mix it. You need to make safe. You have the same quality at all time. And that's the big points on my list. To automatize this mixing, to automatization, the post-processing, the support structure to bring them off the parts. That's one of the big points, I think. And yeah.
So post-processing and pre-processing are the hurdles we are facing now. It's not focusing on the printing part, so to say. Martin, at Audi, when you talk to, let's say, traditional production colleagues, and you are in production, so you talk to them quite often, I guess. In the meantime, do they see, let me ask frankly, okay, do they see you as the freak that is dealing with new technology, or is there acceptance or rather interest already from the colleagues?
There's a huge interest in this technology.
Nice.
Also, the younger colleagues are faced there in their early stages of development with simple FDM printers. And you have colleagues, they come to us and say, hey, I have at home an FDM printer. Hey, that's interesting. You are dealing with metal. Yes, that's stable. Wow, I can use it. And so ideas will develop. So that's also, we are a little bit evangelists in the company, yes. And we have a showroom with some sample parts to bring these ideas out of the colleagues' head. And then it's only the question to start a testing a print for them. And yes, they are interested in more usable handwork systems and so on, that they can have a better working environment.
Great.
Of course.
Great.
But it's a long way. It's a long way to convince these colleagues.
That's why I asked. And I made my own experience, I can tell you, because I'm working in automotive, so I know it very well. It was a pleasure to have you here. Let me quick give a little outlook from each of you. I have a little outlook of each of you. Probably we start with you, Markus, here in the studio. Where do you see AM in automotive in 1, 2, and 3 years? What is your outlook?
I think we will start with the small series production, and we will be very stronger in the future for samples.
Great. Martin, what do you think at Audi?
Okay, so the hype is over, of course. There will be developments in the machining technologies, also in the AM processes, but of course it takes time. And what we learned from the last years, it takes a little bit more time as expected earlier. Also in the high hype phase, where everybody was announced, huge machines, more laser systems, and so on. And then you see in the detail, you look on the details and say, okay, there should be better development. So it takes time, of course.
Okay. So Martin, at EDAG, I mean, you are responsible for future technology. So if somebody can tell us, you can.
Yes, we will see in a few weeks and months some new materials with advanced functions, which are improving and bringing benefits compared to aluminium casting alloys, for example, with 30% higher tightness and crash availability, bringing a benefit for niche vehicles and derivatives. So we will see the first qualified materials, I would say, within 2 or 3 years to be ready for series. We will see I would say, up to 5 years, the first niche and small series applications. And what we will see very earlier than in the metal fraction, we will see advanced polymer parts for individualization in the interior, I'm sure. And what we will see also within the next 2 and 3 years is advanced processes for the automation of those processes to spend and to offer engineering solutions to be much faster in the manufacturing data preparation.
Great, great. So thank you to the three of you. I mean, was exciting, totally different than the last time. And I can tell you, it's crazy how intensive and how positive this is to talk to you and to get more insights. And I think this is what really Formnext Connect is about, and what an exchange in the additive manufacturing industry is about. You always go out of such a conversation with a new insight, a new idea, and a new positive aspect, or at least motivation. And I can give you as a feedback to all three of you, I mean, you are representing one of the, if not the most important, let's say, industry if it comes to our environment right now, and you struggle a lot. But the way you presented your motivation today for additive manufacturing was inspiring, I think, for all of us here at Formnext Connect. Thank you for that. I wish you a lot of success with your projects. I'm keen to see you next year with the new results and the upcoming new technologies, and good luck for the future, and stay healthy, okay? Bye-bye, guys.
Thank you very much.
Bye.
Bye-bye.